welcome. Today in this video what I'd like to discuss is H-adaptive. So here is my C-clamp from project number 3. I've gone through setting up the study. I've applied materials. I've applied fixtures. So again you can see the check mark for the material. In terms of fixture, I've used fixed geometry at the very top. I've applied a bearing load to the bottom, only the bottom half. Remember, I've used a split line for that hole. And now I'm ready to mesh and run. So what we've been doing up to date is going into perhaps mesh, create mesh, and accepting the mesh density that SolidWorks suggested, running, and then creating a mesh based on the SolidWorks suggestion. We would then run and perform a manual convergence setting. There is another way of doing this. This is based on the adaptive methods, and particularly we're going to look at H-adaptive today. So what we'll do is go over to the tree, right click, Properties, Adaptive, H-adaptive. I'll change the accuracy to 99%. The maximum number of loops is 3. We could choose up to 5. This button here should be checked if you're looking at a very complex part where there are areas of uniform stress. Therefore, the H-adaptive method within SolidWorks would actually increase the element size in those areas. But in this case, we're not going to check. I'm going to hit OK. And then we're ready to run. It's going to go through up to 3 loops. There's loop 1. Here's loop 2. And in this case, it only went through 2 iterations. I'm going to deform my C-clamp. That's looking pretty good. I'm going to change my units. There we go. And maybe I'm going to add the mesh. Let's take a look at that. There we go. So what you'll notice right away is that the H-adaptive method within SolidWorks has actually changed the coarseness of the mesh depending on the stress intensity. Where there's high stress intensity, the mesh is decreased. Where there's a lower, more uniform stress, then we get a larger element size. Okay, so that ends the lecture on H-adaptive methods.